there's three tested units. On the AP exam, there are only 3 units. So each unit is a monster. So we're just plowing through 1.4, unit 1, here we go. A polynomial is any function representation equivalent to the analytical form. Don't let all that stuff mess you up. When we say this is your coefficient. So this would be like, I don't know, like 3x to the 10th. And then the next one would be a different number, but x to the 9th descending order. That's all that means. Okay, that's a polynomial. The leading term is which one? What do we consider the leading term in that expression? A sub n, x to the nth. The degree is n, and the leading coefficient is a sub n, right? So let's look at example 1. What's the leading coefficient? 3, and the degree is 4. Be careful with B, the leading coefficient is -7. You guys are gullible. What's wrong with letter B? It's not in descending order. So the leading coefficient is -7 and your degree is 3. How about C? Leading coefficient is 4 and the degree is 0. Isn't 4 the same as 4x to the 0?
Wait.
What's x to the 0? 1. X to the 0. Anything to the 0 power is 1. So 4x to the 0 would be the same as 4. 4x to the first would not be the same as 4. And my problem is 4. Y equals 4, right?
Wait, but if x to the 0 is 0.
No. X to the 0 is 1. So my problem says y equals 4. That's my equation. Isn't this the same as that?
Yeah.
Yeah. So the degree is 0. It's called a constant function. It's always 4. All right. Now we're going to talk about extrema. Those are maxes and mins. And there are actually 4 different kinds of extrema we're going to talk about. We have relative and absolute maxes and mins. Relative, sometimes also called local. He interchanges those words. I don't remember specifically how it's on the AP exam. You need to know both words. Relative and local mean the same thing, and absolute and global mean the same thing. So if we look at the first picture there, I guess the pictures are the same, but if we look at the picture, we have local minimums where? We have local low points where? At -4 and at 0. Those are the low points in that area of the graph. So think of the areas of the graph as like neighborhoods. So your local minimum for the left side of the picture is at -4. X equals -4. You have another low point in the middle part of the graph. You have a low point at -1. Or excuse me, at 0, it's down there at -1, where x is 0. Now, how come I'm not talking about 5? What's going on at 5? There's an arrow. So what's happening there? There's no low point there because it keeps on getting lower, right? It keeps on getting lower. All right, now where are the local maximums? The relative high points of the graph. Looks like we have one at x equals -2 and another one at x equals 3.
Are these supposed to be like in parentheses?
Now those are x values. So it's x equals -4 and x equals 0. They're x values. Now, what about absolute maxes and mins? A curve can have lots of high points and low points, lots. But it's only gonna have one highest point and one lowest point. And that's what we mean by relative max, or excuse me, absolute or global max and min. Okay, so where is the absolute highest point in that picture? At the point, which one? 3, 2. So an absolute maximum is 2. That's as high as the graph goes. And it happens where x equals 3. Absolute minimum? None. Why not? That arrow is going down, down, down forever. There is no lowest point on this. There are the relative low points. You have one on the left side in the middle, but there's no absolute minimum. All right, let's try the same thing.
Would x equal infinity there? Or?
No, there's no minimum. No global minimum, I should say. All right, example 2. Take a look at that picture. Does it have a relative minimum? No. It's got arrows on both sides, guys. There's no low point. It's going on forever and ever and ever. Does it have a relative maximum? Yeah. It happens where x equals 1.
So when there's no relative minimum, what would you write in the blank?
None. Absolute minimum. Does this thing have an absolute minimum? No? No? Does it have an absolute maximum? Yes, it does. Its high point is up at 3 when x equals 1. Every curve can have however many relative maxes and mins, but it can only have one absolute max or min. All right, next picture. B, picture B. Do I have a relative minimum? I do, where x equals -2. Do I have a relative maximum? I actually have another one. I have one's at 3 for sure, but one is also at -4, because that's a point. You see that, no arrow? So I have a relative max at -4 and at 3. Do I have an absolute minimum? No, because of the arrow. Do I have an absolute maximum? Yes, the highest point is at 2, the minimum, or excuse me, the maximum is 2 when x equals 3. All right, now you try C, all by yourself. Does this picture have any relative minimums? Got 2 of them. It has one at -3. where x equals -3 and one where x equals +3. Bottoms or valleys, minimums. Does it have any relative maximums?
Yeah.
It's got one at -4. It's got one at 0. And it's got another one at 5. Does it have an absolute minimum?
Yeah.
Yep. How low does it go?
-3.
-3 at x equals -3. Does it have an absolute maximum? Yep. Its absolute maximum is 4 when x equals 5. Now, if you put an arrow on that 5, 4 point up there, then there wouldn't be an absolute maximum, right? Everybody get that? But because it stops right there, that's literally the highest point on the graph.
I don't understand why we put the relative maximum at -4 at x equals -4.
On the right or left side of the picture, that's the highest point, right? Yep. So you have a high point on the left, on this one we have a high point in the middle, and then we also have a high point on the right. All right, between two real zeros of a polynomial, so remember a polynomial looks like these. So here would be a 0 and here would be a 0. Would you agree with me? In between any two real zeros, there must be at least one local max or min. This one would be a min, this one would be a max. If you have two zeros, isn't your picture going to go up in between them or down in between them? That means you're going to have a maximum or you're going to have a minimum between any two real zeros. So one local or relative max and one local, at least one local relative max or local relative min. Polynomials of even degree. Now, I want you to remember, which BFF is this? Quadratic, so it's y equals x squared. Even degree, x squared. Even degrees always start and end in the same direction. So this is up, and behavior, up. If I put a negative in front of it, it would be down. They always start and end in the same direction if they have an even degree. So x to the 4th, x to the 6th, x to the 10th. All those start and end in the same direction. Well, if they start and end up, then somewhere in between them, there's going to have to be an absolute minimum. If it's down, then somewhere in between them, there has to be an absolute maximum. We cannot say that of odd degree polynomials. Which one is this? X cubed. And what do we know about odd degree? This is true of any odd degree, not just x cubed. They start in one direction and end in the other one, right? Agree? Yeah. Okay. Points of inflection, we talked about these. A function changes from concave up to concave down or vice versa. At a point of inflection, the rate of change of the function changes from increasing to decreasing or decreasing to increasing. That makes sense because if we're concave down, our rate of change is decreasing. But as soon as we change the concave up, our rate of change is increasing. Use the graph of G to answer the following. Can you see any points of inflection in this graph? In other words, do you see any places where the curve appears to go change concavity? Concave down to up or up to down. Do you see any? x values, -1 and 1. Look at where x is -1. Does that look like it's changing concavity? Yep. And how about where x is 1? Yep, good. For each of the following intervals, determine if the rate of change is increasing or decreasing. Okay, this, we could have just done this on our quiz.
For the last question, like, would you, like, for the W, for the absolute maximum, would there be 2x values there?
Absolute maximum?
Or for absolute minimum?
Yes, has 2, because they're both the same. So the minimum would be at -2, and that happens where x is -2 or x is 2. Got it.
This kind of like a random question, but would there be no maximum of like a 25 something range?
Well, yeah, I mean, this we won't even talk about because it's not a function. But yeah, here we have 0 rate of change, so there's no bills and balance at all. Okay, for the following intervals, all right, so what's happening from 3 to 4? From 3 to 4, we are, now, the rate of change is increasing, the function is 2, but the rate of change is increasing because the curve is concave up. How about from -4 to -3? The rate of change is decreasing, oh wait. The rate of change is increasing because we are concave up. Now, what is decreasing? The curve is decreasing, right? The curve is decreasing, going down. But the rate of change is increasing because we're concave up. All right, how about -1 to 1? Decreasing concave down, and 1 to 2. Increasing concave up. All right, get your calculators out. Please pay attention to the domain. It says for t between 0 and 3. Now, it doesn't matter, but to be safe, when I set up my window for this problem, I might just go ahead and let x min be 0 and x max be 3. Now, you don't have to do that, you guys, but your answer is going to come from that interval. So if you graph more than that, you have to make sure your beady eyes are focusing just on the part from 0 to 3. You don't know how to put in the x to the 5th, right? I had to play with my window a little bit. So I don't know what you use. I use for X, I use my min at 0 and my max at 3, because that was given to me in the domain. Y min 0, Y max, I put in 50, I put in some other things and eventually settled on 50. And I got a picture, hopefully I typed this right, I got a picture, looks kind of like this. Anybody else get a picture that looks like that?
Yeah.
All right, so let's understand what it is we're looking for. Based on this model, at what time does the number of cars in the parking lot change from increasing to decreasing? Now remember, this is showing the number of cars in the parking lot. So as long as it's going up, what's happening? More cars? But now it's going down, which means fewer cars. So that problem is just a fancy way of asking you to find what? The maximum. Yeah, it's just a fancy way to say, okay, find the maximum. So second calc max. And my maximum point, 2.446, comma, 31.898. That's what I got for my maximum point. Now we make sure we answer the question. At what time t does the number of cars in the parking lot change from increasing to decreasing? So which of these is t? 2.446. So hours. So 2.446 hours after it opens. What does this number represent? How many cars are in the parking lot? All right, let's look at the back of the inventory stock values. Let's look at the back side. We have already talked about this, but I want to make sure we're all clear on it. So here are my input values, and here are my outputs. Now my job is to figure out what degree I have here. This is a polynomial. They tell me it's a polynomial, so it's not a logarithm, it's not an exponential, it's a polynomial. These are all the same size. Thank goodness. I'm up the creek without the paddle if those aren't the same size. They are. So now I'm gonna find my differences. These are called my first differences. So down by 40, down by 8, up by 72, keep an eye on my arithmetic. 584. Okay, one absolute positive conclusion is this is not linear. Because if it were linear, these would all be the same. Alright, so let's check second differences. This is up by 32, this is up by 80. Up by 512. Okay, not quadratic, because if it were quadratic, these would be the same, right? Up by 40, is that 48?
As someone who may have heard the treatment over during past years today, it is sincere. That is because it is significant as it is very much. Within that sense, it is very much. It is celebrated annually December 6th, both over the country and United States. And the faithfulness, true, and supposed to be in the order of the history, culture, and community.
Did anyone hear a word of that?
Listen.
Okay? We're going on the room, so if you're testing, you will be bound by the standards, and please don't buy have a lot of questions, and if you just want to learn more about it, it would be a great opportunity. And now please off the site.
Thank you so much. Let us now pause to be mindful of all of God's blessings. In the name of the Father, Son, and Holy Spirit, Lord, thank you for the food before us, the Irish family and friends beside us, and the love that keeps us. In Jesus' name we pray, bless us, O Lord, and these thy gifts, which we are about to receive, for thy Son, Jesus Christ, our Lord. Amen. In the name of the Father, Son, and Holy Spirit. Amen.
The degree of this is 4. This is a 4th degree polynomial because the 4th differences were finally the same, right? Okay. This homework's gonna be due on Wednesday.